everyone. Today we are going to learn about how to use SiteMap. So SiteMap is a module in Maestro which is used for the prediction of probable binding sites in a protein structure. So sometimes ऐसा होता है कि आप कोई प्रोटीन स्ट्रक्चर खुद से मॉडल करते हैं या अदरवाइज हमें प्रोटीन स्ट्रक्चर्स एक्सरे क्रिस्टलोग्राफी एनएमआर किसी भी टेक्निक से हमें मिलता है, लेकिन सिंस देयर इज़ नो इंडिजिनस लिगेंड ऑलरेडी बाउंडेड इन दी एक्टिव साइट, तो हमारे लिए ये कैलकुलेट करना थोड़ा मुश्किल होता है कि इसमें एक्टिव साइट्स कहाँ पर होंगी. बट देन दैट इज़ नथिंग टू वरी नाउ बिकॉज वी आर यूजिंग मेस्ट्रो. सो मेस्ट्रो में SiteMap कैन ईजीली डू दैट फॉर अस. सो शुरू करते हैं. सो बिफोर वी डू दैट वी नीड प्रोटीन फॉर वर्किंग ऑन इट. So like I told you, protein preparation wizard. So go to protein preparation wizard and write any protein of your choice. What I have chosen insulin degrading enzyme for this practice. So I'll write the PDB ID of the protein structure I want to work with, and first of all going to import the structure because we cannot press the pre-process button unless I have imported the structure on my Maestro environment. So let's wait for it. Okay, so as you can see, the protein structure is on my screen right now. The the blue ones and the red ones are the area which need our attention. So let's pre-process it now. Alright, now the job has finished and you can see that the protein has been pre-processed. So let us see if there are any problems in the structure. So there are no problems to report. So that means we are good to go. And now we have this protein with us and this is ready, and you can see the ligand attached to this protein chain. I am not going to delete this ligand for this exercise because let us find out whether the algorithm is sensitive and capable enough to find this place as a binding pocket or not. So let's see. So what I have to do is I have to go to task and I can simply write SiteMap. So I can see it here, so I'm not going to write it. It says SiteMap. So this particular module is to visualize whether there are any binding site present in the protein structure. So I have already selected the protein in question. So what we are going to do now is we are going to simply run it. It has few settings. So by default it says identify top ranked potential receptor binding sites, and which means all atoms in the workspace constitute the receptor, which means the algorithm has to run on the entire protein. You can read the settings here side by side while it is running. It says that in order to predict a binding site, it needs at least 15 points to be reported as a site, which means that in a active site at least 15 residues are going to be there, and it is planning to report up to 5 sites at least. So we already know that the active sites are mostly in the areas which are hidden and away from the water. So we know for a fact that the binding pocket is going to be comprised of the amino acids which are hydrophobic in nature. That is why this algorithm is using a more restrictive approach while it is identifying those 15 amino acids which can be a potential, which can constitute a potential binding site. So now our result has come, and you can see that the result has been automatically uploaded on the workspace navigator for us to see, and these are all the sites which have been predicted to be the probable binding pocket. for our protein in question. So this is our protein, and you can see the two ligands are already there. So now I am first of all making the protein in the ribbon form, and now let's see where is the site. So you can see the first site is here. Let us look at the second site. So you can see the second site is lying here. This is the third, fourth, and fifth site. So you can see that this part of the protein in this exercise is the one which has the active regions. These are the active binding pockets. So data from the table also. So if you will see that these are your results. So if you will go deep, it will give you the site score also, if you can see it. So the first site has the maximum score, and it is also giving you the size of the site. It is also giving you the volume of the site, and this is how it predicts that which site is best in this. So this is it for today. You can visit the table for the scores of the prediction, and finally you can use these active sites further in your docking experiments. Thanks for watching.